So we're going to start the recording. Okay, so last week we only got to cover five lessons, and we really need to cover 6 a day. So we're a little bit behind last week, and I do apologize for that. But the first lesson last week ended up going 1 hour and 3 minutes. So I'm going to have to take a look at that lesson and see if I really need everything in it or not. Anyway, let's go ahead and get started here. Okay, electrical safety. We're going to talk about safety. Let's see, amateur radio safety. This is T0 for those of you who are following along in the ARRL book. And I did forget to send the page numbers, but we're starting here. This is around, if you're using the digital download, it numbers the pages differently for one reason or another. Because all the preface stuff still gets numbered as regular pages rather than Roman numerals. But I think we're starting around the 75 mark, 74, something like that, the page number. But anyway, electrical safety. Working on amateur radio equipment can be deadly. Now, a lot of people don't work on their own equipment, but there is a little bit of maintenance involved because you have to occasionally change out coaxes. You sometimes have to investigate power problems and stuff like that. Anytime you're working on it, you want to observe safety. Okay, and one of the things as an avionics technician in the Navy, one of the things that I learned is that anytime you're working on anything that can bite you, you probably want to keep one hand out of it. So only work with one hand, because if you're working with two hands and you get bit, current flows this direction through the upper chest cavity, which is sometimes not good. So you want to avoid that if you can. High voltages and currents are possible. Voltage above 30 and current above 100 milliamps are not safe. I think 100 milliamps is the point where you lose voluntary muscle control, but that's information that I haven't gone over for 40 years. So that can be dangerous. Electrical current flowing through the body can cause the following: involuntary muscle contraction due to low currents, burns from heating issues due to higher currents, and disruption of cell functions such as heart fibrillation. Those are all things you don't want to experience. Yes? Yes, it does, very much so. So electrical safety, what health hazard is presented by electrical current flowing through the body? Delta looks correct, and it is correct. All these choices are correct. Okay, and who was that you, Steve? Mike did answer that? Delta? Okay, you notice he's answering with phonetics, and it's a good time to get started using phonetics. A lot of times on the 2-meter band, people just don't do it. And you can tell the ones who don't spend much time on HF, because when they get on the repeaters and check into a net, and the net control says, let's do it with some form of the phonetic alphabet, even if you have to make up your own. And you can tell the ones that don't, because when they read off their phonetics, they're reading it from a piece of paper very, very slowly. And then when they rattle it off right after that in just regular letters and numbers, it's zip, just like that. So you know which one they're using most of the time. Yeah, if you can, answer Alpha, Bravo, Charlie, or Delta. Okay, if everybody can remember that. Okay, electrical safety. Use 3 wire outlets, cords, and plugs that are properly wired and grounded. And anything that you buy now is going to have a 3-wire cord with it. And so your outlets and the plugs on the end of the cords should be the same. I think I have 1 outlet in my house that's not yet converted to 3. I'd have to look into that. Anyway, 120 volt AC circuits in the US use 3 wires. Neutral is white, hot is black, and safety is green. Now, sometimes it won't be green, sometimes it'll just be bare. All station equipment should be connected to a common single point safety ground. So when you set up this is something that I'm trying to plan out now. When you set up your station in your house, if you're going to set up an HF station, everything, the case of everything should be grounded to a common point so that everything stays the same. And this is also the same reason why they're going to tell you later that wherever you have your antenna entrance into your house, you should have a lightning protector there and a ground rod. Now, ground rods by Florida building codes are supposed to be 8 feet now. And you might think that it's easy to put 8 feet of copper, 3/8 inch copper post into the ground because it's Florida. It's sand, right? It should be nothing at all to get it down there. Not the case. Sometimes you got to work on it a little bit. Maybe change the location. But at some point here in this lesson, they're going to say that you should be bonded. Okay, so wherever you put that ground rod in for your station, it should be tied by heavy gauge single conductor copper wire to your utility ground. Now, the reason for that is differences in the ground. If they're connected, then they're connected. They'll stay even. They'll stay the same. No solder on grounding. It has to be pressure connected, okay? But if they're connected, then they'll stay the same, even if the ground is different and provides a little bit different route. What causes problems is when you have your ground connection at your radio, at your antenna, is so many ohms to ground. It may only be 2 or 3, and then you've got the utility ground at 0 ohms, and that difference will cause problems. So you want to keep it as close to the same as you can. I don't know if this is going to work out for me or not, but we'll find out. The place where my wife gave me to put my radios is actually right next to the electrical service. It's like 8 feet from the electrical service, 6 feet on one wall and 2 feet on another wall. So I don't know if having the electrical service right there on the corner of the building in that room is going to cause any interference or not. I might end up having to work on that a little bit. Let's see. All station equipment should be connected to a common single point safety ground. Copper strap or braid is preferred. Strap is probably your best bet outdoors. And if you can't go with strap, then like I say, a heavy gauge single conductor wire for your ground. Braid is not really good for outdoors because stuff will get into the braid and cause corrosion and stuff like that. High voltage circuits should have interlocks. So, and does everybody know what they mean by an interlock? If you go to take a radio apart and take the cover off of it, there should be something there that shuts off any high power when you take off the cover. So most modern equipment is going to already have that built in. Let's see. Okay, so here's a little example of bad grounding. You'll notice you got your shack ground B on one side and your service entrance, your utility ground on the other side, and they're not connected except for through the house wiring, and house wiring has its own set of issues. So let's see if it gives okay, in the United States, what circuit does black insulation indicate in a 3-wire 120 volt? She said hot. Bravo. Okay. Hot. Bravo. Okay, what is a good way to guard against electrical shock at your station? Install mechanical. Delta sounds reasonable. Very good. Electrical safety. Okay, so there wasn't a drawing there. I wish there was a drawing to show, but the thing is, there's so much. I wish there was a drawing to show what a good safety ground would look like. But there's so much. You can read book after book after book, talk to ham after ham after ham, engineer after engineer after engineer, and you're likely to get a different answer from everybody. The thing is, when you set it up so that it satisfies the way you interpret it, and pray for the best. Okay, so fuses or circuit breakers are used to remove power or prevent excessive current or overload. Now remember that a circuit breaker is a little slower than most fuses, and then within fuses you've got fast acting and slow blow. So you've got all different time frames there. Fuses or circuit breakers should be installed only on the hot conductor. All right, anybody object to that? Okay, this is the way I was raised. Fuses, circuit breakers always go in the hot side. Some of the radios that you buy now, and there's evidence to support this, mobile radios. I'll say mobile radios. Some of the mobile radios you buy will have a fuse on the red and a fuse on the black. Why, I'm not sure, but there are people that are passionate about this. So, and I've seen people go and build new cords that have and actually one of my radios at home has a factory produced fuse housing that has 2 blade fuses in it, one for the red and one for the black. And that's a radio that was built from late 90s to around 2004, I think. Might be a little later than that. Could be. Yeah. Should be installed a hot conductor only. Let's see. If you're only going to have one fuse, it should definitely be on the hot side. Fuses should be sized for the maximum current of the load. Definitely don't go oversize on the fuse because it's there for a reason. It's there to protect your radio from excessive currents. Never replace a fuse with a larger value. And they say it could result in a fire, but I think it'd probably damage your radio and shut it off before it could produce a fire, unless you're way bigger. Electrical safety. What is the purpose of a fuse and an electrical circuit? Sorry? Bravo, to remove power in the case of an overload. Very good. Where should a fuse or circuit breaker be installed in a 120 volt AC power circuit? In series with the hot conductor only. And for this test, even if you believe that you should have one on both, for this test, that's the correct answer. Why should a 5 amp fuse never be replaced with a 20 amp fuse? Excessive current could cause a fire. Thank you very much. Electrical safety and power supplies. Always disconnect, and this is what I do. I mean, for the stuff that I have right now, if I'm not actively using the radio, the antenna is not connected and the power is not connected. And right now I don't have a lightning detector at my house, but at some point I'll get a lightning detector, and if it gets active, then I am using a radio, then I'll just disconnect everything and postpone my activities. Always disconnect power before working on equipment. Power supply capacitors. Okay. Many of us have worked in electronics for quite some time, and you know that capacitors store energy. Okay. So, and the discharge rate is usually slow because there's a resistor in the circuit that makes it discharge off very, very slowly. So when you unplug, when you turn something off and unplug it and you have to work on it, give it a few minutes, let it discharge. The other thing you can do is use a shorting bar. So you alligator clip to the ground or anything that goes to ground, and then touch the capacitor with the probe, and it'll short through it. We had one of these that, it was about that long with the handle and all, and about yay big around, that we used to discharge capacitors and radar equipment in my shop on the USS Saratoga. Make sure capacitors are discharged. Measure the voltage across capacitors. If there's any question at all about what it has on it, check it to make sure. Always, and there you go. Always keep one hand behind your back. It's really, really hard to do. Felix Paguagua, AT3 Felix Paguagua, a good friend of mine at AIMD in Cecil Field. He worked day shift. I worked weekend shift. On Friday, when day shift got all the work off the bench, they were able to leave. And same thing for weekend shift on Monday. The weekend shift worked Friday, Saturday, Sunday, and Monday. Now we work 12-hour days on Saturday and Sunday. But Felix wanted to go home. He had big plans for the weekend, and he was troubleshooting an ARN52 TACAN. Well, ARN52 TACAN's got a 2400 volt power supply on it. It's a DC power supply, so it hurts, but probably not going to kill you. And that 2400 volt DC power supply provides power to 4 power tubes, lighthouse type power tubes. And when it's blowing a fuse, when it blows fuses, you disconnect certain parts to check, to isolate which part is causing the fuse. So he had isolated the strip, the lighthouses, the 4 lighthouse power tubes. He had isolated it down to that. So you've got these caps pulled off, you've got the wires disconnected, it's laying upside down, the wires are going out like this so they don't short on anything. And he turns it on, doesn't blow the fuse. Everything else has already been reconnected. So he knows it's the power tubes. And the way you figure out which power tube is doing, it's got a Mylar film inside. And what you can usually find is the ring that clamps in there to hold the tube sometimes pinches the Mylar. When it pinches the Mylar and it starts to arc through the Mylar, that's what causes a fuse to blow. So what you do is you start with the first tube and you reconnect the power. You turn it on again. If it doesn't blow it, you know it's not the first tube, and you just work your way down like that. But you got to turn it off and let it sit for 5 or 6 minutes before you can touch it. Yeah, Felix said, oh, screw that 5 or 6 minutes. I want to go home. And he left the shop early that day, but he didn't go home. He went to the hospital. And he's Paguagua. He's a Mexican fellow, and he had that straight, perfectly straight hair. And when he touched that, he was sitting on a steel stool on a concrete floor because one corner of the stool was on the concrete rather than on the rubber mat. So when he touched that, he came up off the stool about 3 or 4 inches. There was a blue spark between him and the stool. The stool came up off the floor about 3 inches. There was a blue spark between the stool and the floor. And Felix's hair stood straight up, so it looked like a perfect ball. And nobody had a camera handy because that was before these. But the thing is, it's a funny story now because he made it through it. He came back to work on Monday with a little shake. But the thing is, he didn't go home. He went to the hospital. He spent the night in the hospital before they would let him go because they wanted to hook him up to a monitor and make sure his heart was functioning. So yeah, always keep one hand behind you. Yeah, that would have been worse, without a doubt. So anyway, yeah, keep one hand behind your back and be sure you always let those capacitors discharge. And that power supply, that 2400 volt power supply is just a bunch of capacitors inside it. And so you have to give that time to leak off. What hazard exists in a power supply immediately after turning it off? Delta, charge stored in filter capacitors. The filter capacitors smooth out the DC. Electrical safety, 12 volt storage batteries present several safety hazards. Shorting the terminals can cause burns, fire, or explosion. Lead acid storage batteries contain sulfuric acid, which has a tendency to leak. Rapid charging or discharging can cause overheating or outgassing. And hydrogen gas from storage batteries is flammable and can cause, and this is why there's a specific order that you connect your jumper cables in, is because, yeah, that hydrogen gas can be a boom. I've got my very first ever uh, lithium iron phosphate battery, LifePo 4 they call it. I've got the very first one I've ever had, but I've heard from some people who have taken them apart after they've had them long enough that they no longer function. And apparently it's just a bunch of cells inside that battery. So those are fairly safe as far as they're not going to leak. They don't necessarily have to be in any particular position to be effective. But they can discharge quickly and cause fires. So most of them, I think they have a monitor built inside of it that regulates everything. But anyway, electrical safety. Okay, which you see, I haven't noticed this. You see the T0A01. That means it's the very first question in that series. T is technician, 0 is the sub-element, and A01 would be group A, question 1. I hadn't noticed if the rest of them were doing that or not. Which of the following is a safety hazard of a 12-volt storage battery? Bravo. Shorting the terminals can cause burns, fire, explosion. Remember, they can discharge fairly quickly. What hazard is caused by charging or discharging a battery too quickly? Alpha, overheating or outgassing. That sounds reasonable. Yeah, and see A10, so that was the 10th question. So takeaways from this sub-element right here, and we're looking at 26 minutes right now, so we did much better on this one than we did the first one last week. Electrical shock may cause damage due to heating of tissue, may disrupt cell functions, causing your heart to act strange. May cause involuntary muscle contractions, again, make your heart do weird things and make your hands stick on there so that you can't let it go. Funny story here. One of the stories, in every shop in the U.S. Navy on the ship, there's a broomstick that has no broom on it, and there's a web strap. And they are specifically for getting people off of a hot circuit when they can't do it themselves. Because what you shouldn't do is touch your buddy, because then you get the shock too. So you use a broomstick and push him away from it. Okay, and always there's somebody that says, oh, okay. They look around and see who they want to get shocked so they can wail on them with the broomstick. And you've got the web strap that you can sling over them and pull them off. And as a last, I'm not as young and spry as I used to be, but as a last resort, the bottom of your boot that you wear on the ship is isolating, so you can put your boot up against them and push them off. Now, I couldn't do that anymore because I can't raise my leg that high, and I don't have that kind of balance anymore, but it works. Prevention: use 3-wire cords and plugs, connect all equipment to a common safety ground, and be sure that any equipment that you have to open has functioning mechanical interlocks in high voltage situations. Fuses and circuit breakers removes power in case of an overload. Should be installed in the hot lead, which is black. So for house wiring, it's going to be installed, that's where you've got a common bar that the white goes to, and then the black all go to the circuit breaker. Larger current fuse could result if you install a larger fuse than what is intended to go in the circuit, then it could result in excessive current and possibly a fire. Power supplies may contain high voltage and filter capacitors even after you turn it off. My power supply, when I turn it off, everything stays lit up for about 40 seconds. I mean, even though I've turned the power off and disconnected the cord, the lights stay on, the meter stays on, and then you watch it slowly drop back down. It takes 35 to 40 seconds for that to all happen. And at that point, it's pretty safe to assume that it's safe to open it if you needed to. Storage batteries. Shorting the terminals can cause burns, fires, or explosion, and excessive charging or discharging current may cause, overheating or outgassing. Any questions before I stop the recording? Okay.